So my name is James. I'm the academic manager at Varsity Unlimited Tutors. We are an academic consultancy company that specializes in assisting students with their studies. What we do is we do some extra lessons for the students that need those extra lessons. Usually for first years, we have extra lessons for business mathematics. We've got extra lessons for economics 1A. We've got extra lessons for analytical techniques in business. Those are the main three subjects that we have. But we also assist even in all the other subjects in case you need assistance in those subjects. You just send me a text message on my WhatsApp, and I will definitely respond to you and highlight how we can assist you, right? We need to be straightforward again. We are a private company. We are not directly related to Mancosa. So you guys are going to have some webinars with Mancosa that are separate from this one. But this is in case you need that extra help in economics or in business mathematics, just to make sure that you cross the finishing line. We are there to assist you. Now, in terms of the lectures that we provide, what we do is we go through your assignments with you guys so that you can know how to answer your assignments, how to make sure that you get a 10 out of 10 in the two assignments that you're going to write. In addition to the assignments, we also go through the material within your study module so that you can prepare for the examination at the end of the semester so that you can get your distinction at the end of the semester when you do the exams. So there are a number of students that we've done with in the past, and they are always happy with the service that we offer them. So what we usually do is we do some free lectures, usually 1 or 2 free lectures, so that you guys can actually see us and also just see what you'll be getting if you continue being interested in our services. Then for those that are interested in the services, the cost is around 650 rand for the entire semester for that specific module that you are interested in getting extra lesson in. But for today, and I think the next lecture, don't worry about payment. These ones are for free, just so that you can acclimatize yourself and introduce yourself to the subject, and you can have more information on this specific subject. Like I said, I'm going to post this on YouTube, and I'm going to send some details in the group so that you can also just know a bit more information. Now, your lecturer today, his name is Mr. Kuda Sivanda. He's a statistician. He's one of the guys that we trust very well, that he can do very well with mathematical subjects, with statistics, with IT, and etc. So he's here to help you guys out. He's going to introduce the subject. If you've got questions, you can go ahead and ask him. He will answer the questions for you. But let's just give him a moment to at least just present a little bit, and then when the questions come, he will be free to answer them. Then, like I said, this session is recorded for you. We'll post the link in the group so that in case you want to revisit some of the concepts, the introductory concepts that he gives, you will be able to do that. Then, Mr. Svanda.
Yes. Thank you very much, James, for the warm welcome. I want to welcome you all once again to business mathematics. Like James had highlighted, Mr. Svanda or Kuda, I'm the one who's going to take you through this module for business mathematics. So, like James had highlighted, this module is more of a practical module because it's mathematics. Mathematics is not a theoretical module; it's practical because it involves some working. So today is just an introductory lecture, just to allow you just to have an overview of how I'm going to deliver the lectures that you're going to have. So without wasting much of your time, let me share just a couple of slides that I have managed to make up for you guys. So basically, it's just going to give you an overview, right? Like I said, just going to give you an overview of how we're going to be delivering these lectures to you guys. All right, so what are we going to cover basically in this this module. So your study module, it consists of five topics. So there is a topic on business mathematics. There is a topic on percentages, algebra, ratios and proportions. And lastly, there is a section dedicated to linear graphs. So basically what I'm going to do is today, as I'm going to give you an introductory lecture, the best way I could deliver the best lecture was to start a little bit on unit 1. We're not going to cover everything, but at least I'm just going to give you a foretaste of how this lecture will be like. So I'm just, without wasting much of your precious time, I'm just going to delve in deeper into the concepts that are being covered in unit number 1, so that at least when this lecture is over, you can have an overview of how we actually deliver content from your study module. So this is an overview of this lecture, right? So we're going to cover, I'm not so sure if I'm going to cover everything, because remember, this is an introductory, right? But what I plan to cover is to cover basic maths, mathematical operations, fractions, and decimals, right? So basically, you know, a lot of people I know, they are afraid of this animal called mathematics, right? But we are here to make life easier for you. So I'll try by all means to simplify it, so that at least each and everyone can grasp the concept, right? What is much more important. That's my aim. So I'll start by defining some of the things before we delve in a little bit deep, so that at least we are on the same page. So let's start by talking about basic arithmetic, right? Basic mathematics. So let's start by defining what a whole number is, right? So the simplest type of numbers in our number systems are those represented by symbols 0, 1, 2, 3. So when you're talking about numbers, that's the first type of numbers, right? That that comes into your mind. So the popular term that refers to these numbers are integers, right? So they are used to count whole objects rather than fractions or part of them. So that's the reason why they are called whole numbers, right? Because they are used to count whole objects rather than fractions or parts of them. All right. So that is the definition, right, for whole numbers. So basically, we'll be dealing in this course, we'll be dealing with whole numbers and fractions and decimals, right? So maths cannot be maths without what we call mathematical operations, right? Because maths, you are not, it's not a theoretical subject where you're just writing words without trying to derive anything from it. So maths, there has to be what we call multiplication. There has to be division, addition, and subtraction. All these are what we call mathematical operations, because there are some operations that you have to do when you are dealing with mathematics. All right. So basically, multiplication is often represented by the times, and division is often represented by this division sign or the forward slash. Then addition, that's the plus, and subtraction, that's the negative. So the order in which this operation should be performed in an expression is multiplications and divisions first, and then additions and subtraction. Okay, so there is an easier way, right? Because this is very, very, very important. This section here is very, 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 very important, because there are some instances you come to find out as we are delving a little bit deeper, as we do more and more examples, right? You come to find out that there are expressions, right? An expression where you have a mixture of multiplications, division, addition, and subtraction. So there's what we call the order of precedence of solving a mathematical expression, right? All right. Okay, guys, can you confirm if you can hear me? All of you can hear me correctly. There's someone who's saying they're struggling hearing me. So Kindly
I
confirm.
can hear you loud and clear.
Okay, all right. Thank you very much. So I think maybe it might be a problem from their side, right? Because the others they just confirmed now that they can hear correctly. All right, no, that's fine. So let me continue, right? Okay, so basically I was saying there's what we call a precedence of what? A precedence of solving a mathematical expression, right? That involves various mathematical operations. So for now, don't be confused with what I'm trying to say, because what I'm just trying to say, I'm going to practically show it to you. So what you need to know is when you are given a mathematical expression that has various mathematical operations within it, you need to follow what is called BOMDAS, right? BOMDAS. Okay, so BOMDAS basically, B, it means the brackets, right? Which is this bracket. So the bracket is also another sign that is represent multiplication, right? So brackets of also, right? Of, I think some of you have seen it, that have done maybe some mathematical modules before. Of, right? Or F, it also represents multiplication. Then M is multiplication. Then D, that's division. Then A, that is addition, and then S, that is subtraction. So these first three, right? Boom. This is the multiplications, right? Then this D, that's the division. Then this A, that's the addition. This S, that's the subtraction. So you must understand this. Okay. Then another person might say, Mara, well, you are saying BOMDAS, but I have heard of BODMAS, right? To those who hasn't had this, don't worry, right? But I know there are some people who have made this type of can I say acronym or something, or representation of this mathematical operation, right? So someone might say, what's the difference between BODMAS and BOMDAS? In theory, it's the same, right? In theory, it's the same. You will still get the same answer. But according to this module, your lecturer does not use BODMAS. The reason why I'm saying so is because last semester, I think it was within your KCQ. I want to believe that you guys, I think you do maybe a KCQ, if I'm not mistaken, right? There was a question within a KCQ where the lecturer was asking you if the students understood, right, the concept of what? Of this thing that we're talking about this BOMDAS and BODMAS. So there were two questions where they actually, one question was using BOMDAS and the other question was using BODMAS. But the answer that was correct there, like I said, in theory, you still get the same answer. But because there was a question that came last semester, which wanted you guys to really show whether you know that in this course they use BOMDAS or BODMAS. So it looks like your lecturer goes for this one, right? So it doesn't matter. In theory, they'll produce the same answer. But like, remember, you have to stick to a certain principle when you're delivering certain information, right? So it looks like your lecturer prefers using BOMDAS. So this is what you must stick with. If a question again is repeated, like the one that I'm trying to talk about, within your when it comes to your KCQs, just make sure that you use BOMDAS. So basically, that's what they're talking about. The order in which this operation should be performed in an expression is multiplications and divisions first, and then additions and subtractions later on, right? So let's delve deeper now into some of these practical things, right? So let's start with multiplication, right? So multiplication, so these are the four variations, right, that you can find a mathematical expression when it's talking about multiplication. So this is the first one, right? This is the first one where you are using the multiplication sign. Then this one, you're using the dot 5.7. It's also it also represents multiplication. Then the brackets, remember BOMDAS starts with brackets, so those brackets or parentheses there, it's also what? It's also multiplication. So it doesn't matter whether the parenthesis is within 5 is within the parenthesis or 7 within the parenthesis. It does, the order there is not important, right? It's still the same, just like here, whether you start with 7 or you start with 5, it's still the same, right? It doesn't matter. So now let's look at an expression, this one, right? So let's see how we are able to solve this out. So what we need to understand is, remember, we use what BOMDAS, right? So this is a mathematical expression that is involving more than 2 mathematical operations, because there is a subtraction and then there is a multiplication. So according to BOMDAS, right, the first thing on all those operations, let's look, do we have brackets? Yes, we have brackets. So you must solve the things within the brackets first. That's where BOMDAS comes into play. So now we are using that BOMDAS now. You know what? In like I told you, that even if you didn't understand it when I was trying to say it in theory, but now we are now putting it into practice, right? Realistically, right? So now we are saying within the mathematical expression, are there any terms within the brackets? In this case, yes, they are. We have 8 minus 5 within the brackets. So what it means, we are going to solve this mathematical part first before we proceed with anything. So in other words, what we do now is 8 minus 5, we get what? We get 3. So this whole thing is reduced into this mathematical expression, 3 times 3, because this 3 is coming from 8 minus 5. So after we are done, 3 times 3, we get 9. This is what they got here. So this 3, the reason why is this 3. What someone was saying, since there's a negative there and subtraction is at the last, were we not supposed to say 3 times 8 minus 5? No, we're not supposed to do that, because 8 minus 5 is within the bracket. So the bracket, according to BOMDAS, is what we evaluate first before we carry on with any other operation. So it's still the same thing with what? With 9 plus 2 times 7. So we can say that 9 plus 2 is within brackets. So that's what we evaluate first, which is 11, right? 11 multiplied by 7, it gives us what? It gives us 70 what? 77. Now we have negative 7 multiplied by negative 8. So basically, right, if you see a multiplication, if a multiplication is accompanied by is followed by a subtraction, or is followed by with a multiplication, okay, multiplication, usually this multiplication is this one, right? So in this case, this term here, we can write it as plus 5 multiplied by plus 7, right? But because it's this plus is ignored, that's why it becomes 5 by 7. So basically, let me just erase this, right? Okay. So when a multiplication is accompanied by negative, you act as if this multiplication is not there, right? You act. Connect audio. Okay. I think there are guys. Okay. Let me just ask. James, are you addressing this to the other student?
Yeah. There's someone struggling with audio.
Okay. All right. Thank you very much. Thank you for attending to that. All right. So let me just continue. Right. Let me just continue. Okay. Someone is saying repeat B for me. All right. So, okay, before I continue, let me just repeat B, right, since someone had requested that. Okay, so what we are saying is here, right, we just don't solve maths in any order, right? When you are given a mathematical expression, you just don't solve it the way you feel. There are rules and regulations that accompany the solving or the evaluation of a mathematical expression. So in this case, if it is just a simple mathematical expression, including mathematical operations, right, we must adhere to what we call the Bohmdas rule, right? So now for us to evaluate and to calculate this mathematical expression, the first thing is, according to Bohmdas, is there any an expression within the full expression, right, that is within brackets? In this case, yes, we have 9 plus 2. It is enclosed within parentheses. It is enclosed within brackets. So that is what we solve first before we solve anything else. So within the brackets, we have 9 plus 2. So 9 plus 2, it gives us 11. So we reduce this whole mathematical expression to just 11 multiplied by what? By 7. So we get 11 plus multiplied by 7, which gives you 77. All right, that's fine. Then going to the next, right? Going to the next. So I'm not so sure if is it a corner? If can you just confirm if you really got me on that part? So going to part C, I was just saying, when you see a multiplication being accompanied by a negative, right, you act as if that multiplication is there. You ignore it. You just ignore it, right? You just like a division also is accompanied by a negative. You just ignore. You act as if it's not there. So in this case, no, sorry, not okay. All right, sorry. Let me reverse that. I'm mixing up something. No. When a multiplication, right, is accompanied by a negative sign, you mustn't ignore. Because I was mixing up with what? With plus and negative, right? Don't worry, we're going to cover that up later on. So if it is a multiplication, what you do is you don't ignore, right? But what we are seeing right now is, in this case, we were multiplying a positive number and a positive number, right? So, and we go to what? A positive number. So let me explain something here. Let me explain 4 scenarios that you can get when you are multiplying numbers, right? So there is an instance where you can say a negative number, right? Multiplying a negative number, which is, in this case, it's -7 multiplied by -8, right? That's the first instance. Or you can get a negative number, right, being multiplied to a positive number, right? Or you can have a positive number, right, being multiplied to a negative number. Or you can have a positive number being multiplied to a positive number. So these are the 4 various variations that you can get when you are multiplying 2 numbers, right? It's either both numbers are going to be positive, or one is going to be negative, or both of them, they're going to be positive. So what will be the outcome of each, right? So for the first one, when a negative number multiplies a negative number, these negatives, they cancel each other, they become a positive. So when a negative number multiplies a negative number, you get a positive number, right? But when you are multiplying a negative number with a positive number, the negative sign has more weight than the positive. So when you are multiplying a negative and a positive, you will get a negative, because the negative has got what? More weight, which is the same thing. When you multiply a positive with a negative, you still get a what? You still get a negative, right? And when you are multiplying a positive with a positive, you get a positive. So coming to C, you can see, right? Coming to C, you can see that it's a negative number multiplying a negative number. So basically, negative multiplying negative, it means that these negatives, they cancel each other. In other words, we are just left with 7 times 8, because the what? The negatives, they cancel each other. right? So when you remove the negatives, 7 multiplied by 8, you get 56. So you get your positive 56. So I'm hoping that you really got me here, right? When a positive number multiplies a positive number, you get a positive. When a negative number multiplies a positive number, you get a negative. When a negative multiplies a negative, you get a positive. So that's the rule that I was just trying to put further across. Now let's talk of the division side, right? So there are 3 variations, right, to this subcategory. So you can find that there is a division where you use a forward slash, or you can use the division sign as we know it, or you can just underline the number. But this is you rarely see the 3rd variation, right? The most common is what? The most common is the first and what? In the second. So basically, when they say 15/5, basically what they're just trying to say is they're saying 15/5. That's basically okay. I think that's the reason why they are putting this line under, right? They didn't put like I think the person who printed this module, they forgot to put the denominator, right? So what you need to understand is when you are dividing, right? So 15/5 is just the same as 15 forward slash, right? 5 is just the same as saying 15/5. So basically that's what it means. So in this case, it means that 15 gets into 5 gets into 15 3 times, right? So now let's calculate. Let's calculate these issues. So there are again also 4 variations that you need to understand. So when when a negative number, right, divides itself with a negative number, right, then there is a negative number being divided by a positive. Then we have what? A positive number being divided by a negative. Just don't mind my handwriting for now, because I'm using improper methods to be writing on the screen, right? All right. So okay, this is supposed to be not equals. It's supposed to be all right. So when a positive is divided by, when a negative number is divided by a negative number, you get what? A positive. Just like just like multiplication, right? When a negative number is divided by a positive, you get a negative. When a positive is divided by a negative, you get a negative. And when a positive is divided by a positive, you get a positive. So those are the 4 variations that you're going to come across with when you are doing your division. So based on those rules, let's try to see if we are able, right? If we are able to tackle, if we are able to do something, right? Based on what we have managed to do. So now this -3 over what? Over 6. So this -3 over 6. So basically, I know you'll be using your calculators, right? You just punch in. So remember, this is a negative number being divided by a positive number. So obviously, the number that you're going to get, it must be a negative. So we already put a negative here. So doing this division traditional, so you say 6 into what? Into 3, it can't, right? So it's a 0. It's a 0, right? It can't, it means it's a 0. Then you put a comma. Then you add you carry 0 here. 6 into what? 6 into 30, it's 5. So 0.5 is equivalent. It is the decimal part of what? Of half, right? It is a decimal of what? It is a decimal of half. So the answer will be a -half. That's the reason why you you get this part. But like I said, you don't have to really stress yourself in trying to what? In trying to make yours, to interpret or to do the working itself. Because in this course, you can still use the calculator, but they want to see the workings. They want to see the workings, but you can still use the calculator to evaluate your steps. So in this case, -3 punch. If you just punch it, -3 divided by 6, you get -0.5. Now, in this case now, in the next case, we are saying it's -20 divided by a -4. So it's a negative number divided by a negative number. So basically, we are going to get a positive. It's a positive something. So 4 into 20, it gives us what? 5. So that's a positive 5, which is this 5 that we have here. Then the last one, it's 5/30. 5 is a positive number, 30 is a negative number. 5 into 5, 1, right? So how did they come up with 1/6? So it's 5/30, right? So 5 into 5, it gets 1 times into 5, right? 5 into 30, it gets 6 times, right? So you have simplified 5/30 to its simplest form by saying 1/6. So, all right, so I'm just assuming we are still on the same page. We are still on the same what? We are still on the same platform, right? So now we have dealt with multiplication. We have dealt with what? With division. Now let's go to the section where we are talking about addition and subtraction, right? So remember, we said mathematics, it has rules that governs them. It has got some principles that you have to adhere to, right? So you just have to make sure that you really do understand those things, or else the bad part of maths is when you are wrong working out something, the answer will not say you are wrong. You produce an answer. You see, that's the bad part of maths. Maths, you always come up with an answer, but the thing at the end of the day is whatever you have produced, is it the correct answer that is being asked, right? So that's why it's much more important to adhere to these principles and rules so that people may not make mistakes when they are what? When they are doing their mathematical expressions, right? Evaluating their mathematical expressions. Also, right, so addition does have symmetry. The order in which the numbers appear does not affect the result. So what are they trying to say? Let's look at that example there. They're saying the expressions 2 + 3 and 3 + 2 are the same as they both give a result of 5. That's what I was saying to explain to you. Whether you interchange when you're saying 7 times 5, or you interchange by saying 5 times 7, it's still the same. They are symmetrical, right? When you are doing division, when you are doing division is not symmetrical, right? The only two operations that allows symmetry is multiplication and what? And addition. Those ones you can swap, right? You can swap the terms and they can still make sense. But for subtraction and division, when you interchange like this, then it loses meaning altogether, right? Let me give an example. For multiplication, I will not give an example because it's straightforward. But for division, let's say 3 divided by 6, right? And then let's swap these two. They need to be 6 divided by 3. Can you see that the answer we get here and the answer we get here, they're not the same? There we get half, on the other part we get 2. So division is not symmetrical, as well as subtraction is not also symmetrical. So you can see for subtraction that 8 minus 3, if you interchange them, it becomes 3 minus 8, it loses meaning altogether. Here you get 5, there you get -5. So those are different. The number looks like it's the same, but the sign makes them different. -5 and 5, those are two different separate entities. They are not the same. They look the same, but they are not. They are really not the same. All right. So basically, when indeed reversing the order of the numbers resulting, okay, we're just explaining that part. So when performing multiple additions and subtractions, you should treat a positive and a negative sign immediately next to each other as simply a what? A negative. So what they're trying to say here is you have a scenario where you say maybe 3, right, plus, then you say negative 2, right? So they're saying when you have a positive sign and a negative sign immediately next to each other, which is these two, right, plus and the negative, they say the negative has got more weight, so you act as if that positive is not there. So this positive is removed, so this becomes 3 minus 2. So the negative has got what? The negative has got more weight on that, right? So I want to believe that you got the concept there. So let's look at what is called a fraction, right? What is called, so basically what we were dealing about there, those are the mathematical operations that are used on both decimals and fractions and whole numbers, right? So we defined what a whole number is. Let's define what a fraction is, right? So a fraction is an expression that appears in the form A over B, right? A on top of B. So basically, what I need to explain here is these terms, they have got their names, right? Where this A is called a numerator, right? Which is what they said there. Okay, yeah, this word, which is a numerator, right? Then the bottom part, they call it a denominator. So a fraction is called a fraction because it is a numerator on top of a denominator, right? Basically, that's what a fraction is. Now, that being said, fractions can then further be divided into 2. Because you have 2 scenarios, you have 2 variations of what? Of fraction. Let me give you an example before I explain. You can have a scenario where you are saying 3 over 5. Then you have a scenario where 5 over 3. These are 2 variations of the fraction. Because as you can see on the first part, the numerator is smaller than the denominator. But on the second part, the numerator is bigger than the denominator. So these are 2 variations of what? Of fraction. So basically, when a numerator is less than the denominator, that type of a fraction is called a proper fraction. That's what a fraction must be. That's what they call it, a proper fraction. But there is an instance where a numerator is greater than the denominator, right? That's when now we call it an improper fraction. So fractions have got 2 variations. They've got a proper fraction. A proper fraction is when a numerator is less than a denominator. Then we have another variation, which is called the improper fraction. It's improper because that's not how a fraction must be, but it's another variation of it, right? So a numerator is bigger than the denominator. That's what happens when you have a proper and improper fraction. All right, so let me see. Okay, so I think for today, but mathematics, you guys, you end up being saturated, right? I just wanted to give an overview. So I'm just going to deal on addition of fractions with the same denominator, and then we call it what? We call it a night, and then later on we'll continue from there. Remember, this is just an introductory lecture, just to what? Just to show you how we are going to deliver the information. As some of you have seen, you can see that I'm taking these examples from directly your study module, right? I think some of you have actually seen it. So I'm actually attacking this. I'm actually delivering this lecture using the content within your study module, so that at least even if when you cover it in class, it will be just a repetition for you, right? You would have managed to to cover it. So let me do these two examples, and then I hand over the time back to James, unless maybe there are some people who've got questions regarding what we have covered so far tonight. All right, so let's see. Let's see. We want to add the following fractions, which is 1/8 plus 1/3. So 1/8 plus 3/8. Sorry. So what you see is your study module just gives you the solution. They don't explain to you the processes that you have to do to get to the final answer. So that's the reason why I'm taking my time to explain these fundamentals, this foundation, so that at least you guys, you can really have an idea of what these guys were doing, right? So what you do is, there are two scenarios. When you are adding fractions, there are two scenarios. There are two, let me say it like this. So the first scenario is when two fractions, they have the same denominator. Like in this case, this fraction has a denominator of 8, and this fraction has a denominator of 8. So they've got a common denominator, which is 8. Then there is another instance, another variation, where the two fractions have got two separate denominators. So you must understand, right? Those are the two variations, right? But in this case, let's try to attack this one, right? The concept of evaluating the addition of two fractions, it doesn't matter whether the denominators are the same or not, it's still the same, right? The principle behind adding fraction is still the same, regardless of whether the denominators are the same or not, right? So in this case, what you need to do is you need to find a common denominator. You need to find a common denominator between these two denominators. So since they are the same, right, we just take that denominator, right? Since 8 and 8 are the same, we just take 8. So what you do now is you say, for the first fraction, this denominator, 8 into the common denominator, it's 1. Then you say 1 multiplied by 1, you get that 1, right? Then you say plus, then 8 into 8, the denominator of the second fraction, into the denominator of the common, or into the common denominator, 8 into 8, 1. Then 1 multiplied by 3, you still get 3. So in this case, 1 plus 3, you get 4/8. Right? That's easy. Now let's take for an instance where we are saying it's 1/8 plus 1/4. Now 8 and 4 are different, so we need to find a common denominator. Okay, let me not use 4, because 4 is very easy, right? Let me use 3. So a common denominator for 8 and 3, obviously 3 cannot get into 8, right? So it can be. But now a common denominator can be 12, right? 8 gets into 12, 3 gets into 12. So you need to find a denominator in which each of those denominators get into without leaving a remainder, right? So 8 into 12, that is what? Should be 3, right? Should be 4. Mental maths sometimes confusing, but I think it should be 4, right? So 8 into 12, no, it's the common denominator. Sorry, the common denominator is not 12 here. The common denominator is 21, right? Let me just
316.
It's we can take 21, right? Let me see here. It's not 12. It's 21. So 24, sorry, not 21. It's 24. So 8 into 24 is 3 times, right? Then 3 into 24 is what? It's 8, right? So in this case, when you say 3 plus 8 plus 3 plus 11, you get what? 3 plus 8, you get 11. They need to be 11 over 24, right? So what you need to understand, remember, what you need to, I'm just explaining a principle, right? Just forgive me that at first I didn't put the correct denominator, right? But I'm explaining a certain principle that I want you to grasp, because they didn't put it within this example. Maybe we're going to see them later on as we proceed. But they didn't put this as part of the examples when they're explaining the addition of fractions. So they can give you denominators that are different. What you need to do is you need to come up with a common denominator, right? A common denominator for the two denominators, right? So normally what would be the easiest way to deal with this is you find what is called the lowest common multiple. I think some of you have heard this, like they call it as LCM. The lowest common multiple, a number in which the lowest number that these two can get into and does not leave a remainder. So in this case, it's 24, right? Unless maybe there's another number below 24, or which is also a common denominator, right? But it doesn't matter. Even if we were to use 40, let's look for another number, right? Where maybe 3 and 8 can get into. But if it doesn't matter, whether you find another number, as long as it's a common denominator between the two, right? And those two numbers, they get into that number without making a remainder, you will still get the same answer, right? So in this case, you get 11 over 24, right? So in this case now, let's come to see when we add these three, right? So in this case, let me just go straight to this one, right? So 2 over 15 plus 4 over 15 plus 7 over 50. So you can see that all these three, they've got a common denominator. So obviously that's the reason why you put 15 there. So this 15 into this 15, it's 1. 1 times 2 is this 2, right? 15 into this 15, 1. 1 times 4 is this 4 here. Then 15 into 15 is 1. 1 times this 7 is this 7 here. If you add this, you get 13. That will be 13 over 15. All right. So that's business mathematics in a nutshell. So what I'm going to do now is I'm going to give the platform. I'm going to leave this platform to you guys. I hope I didn't want to continue because, like I said, when mathematics, it's something that requires you to think. So I don't want you to get stuffed up with too many information right now, right? Because it's a whole lot of things. Like I said, this course I'll be trying to teach from a fundamental point of view. I'm trying to lay foundation that are even not in your study guides. Because at the end of the day, you guys must be able to do this on your own, right? So basically, that's why you see I'm trying to explain some of the concepts that are not even in your study module, because you need to understand everything from the word. Okay, so for now, I'm leaving the floor to you guys. Is there anyone who has a question? Just feel free. What I do in my lectures is, it's only that this one was an introductory lecture, so I know most of the people might not feel comfortable asking questions. But what I normally do is when I am explaining a certain concept and someone does not understand that concept, I would rather appreciate that you ask a question regarding that particular concept at that particular time, right? So now I don't know if you guys have got any question. If you don't have any question, then James, okay, looks like yeah, you can unmute yourself, Nelly. You can just go ahead and unmute yourself.
Thank you, Kuda. Thank you so much. This was it was very helpful for me because I don't have the maths foundation. So I think the information you've given us today is definitely going to help me. It's going to make me a little bit more comfortable than I was feeling. Just one thing that I would like you to clarify here on the fractions. I got a little bit confused when you said if the two denominators are not the same, then you need to find the lowest common
multiple. Yeah.
multiple. Okay, can you just clarify then if maybe we can say 16? Help me out there with 16 on that example that you were doing. Instead of saying 24, where 8 is going to go in 3 times, just say 16. Like, will that still be fine? Because 8 goes into 16 and 3 goes into 16.
If I can recall that correctly, 3 cannot get into 16. Yeah, it leaves the remainder. So 3 into 16.
Okay.
Yes.
No, it's fine. That's the part that I missed. The fact that it must go in and not leave a remainder.
And not leave a remainder.
No.
Yes.
Now I got you. Thank you so much.
All right, that's fine. Thank you very much for bringing that up. So she brought up a very, very, very important thing, right? I think what she did, if you see that I managed also to do a little bit of a mistake like what she did, right? I put a curve there, right? So at 12, it looks like 3 gets into 12, right? But 8 cannot get into 12 because it will leave a what? It will leave a remainder. So that's why you see that curve, I had to reverse it and I had to find what is called the lowest common multiple. So the lowest common multiple of these two numbers was what? Was 24. So 8 gets into 24 without leaving a remainder, and 3 gets into 24 without leaving a remainder. Thank you very much for bringing that up, because that was a very, very, very important question there. So I'm not so sure if there's also another question. If not, so over to you, James.
Okay. Thank you, Mr. Swanda. I hope you all had a wonderful time. Like I said, we are going to have another free lecture. I'm going to advise you the specific date, but I think it will be either the last week of August or the first week of September, either one of the two. I think it will be the last week of August. I'll just post in the group the date for that free lecture again, where you can come in and just get a bit of advice from our lecturer here, Mr. Swanda. Then I'm going to post a link to this video in the group so that those who want to revise can do some revision also. But as I highlighted at the beginning of the lecture, if you want to go through the whole module and get guidelines and assistance in terms of your assignments and the exams, the cost is 650 per semester. You can pay in installments, but I'll post more details in the group for those that need those specific details and that need that extra help. Thank you guys for coming in. I hope you all have a wonderful evening.
Thank you so much, guys. Bye.
Bye-bye.
Thank you.
Thank you. Bye.
Thank you.
Thank you.
Bye.
Bye.
Bye.